So what we're going to be doing today, we're going to go over the supplemental safety manual real quick, because safety is always the most important part of being successful. You don't want any injuries and people getting hurt. So what we do is we send out this supplemental safety manual with all the machines that we sell. And it's good reference. There's a little checklist for setup people. There's a checklist for the maintenance people. And there's also a checklist for the operators and setup guys, everything like that. So this guy right here is the checklist for the setup guys, what they should be using to check all the safeties on a machine before running the machine. And again, here's more information and another checklist for the setup guys. Then we have the maintenance section. So this is the checklist for the maintenance people. And again, we can send this out. This should come with all your molding machines. Every single molding machine we sell should have this with it. And in case anybody's asking, if you make any guarding changes, you need to inform Absolute High TN. I am the safety manager, so you can send the email to myself, or you can give me a call at the office. My name's David Bodwin, and if you have any questions at all about safety or guarding, please give me a call, because it's very important that if you have your machines and you're bypassing safeties, when the a service guy goes in and sees that a safety is bypassed, we will write a safety letter to the owner of the company to inform them of the safety violations and make sure that they get corrected. So again, this is the specifications that the machines are certified to. We use TUV as our certification company, and it's certified by CFR 1910, the OSHA General Duty Clause, and FPA 79, ANSI SPI B151.1, ANSI B11.19, the National Electrical Code, and ANSI SPI B151.27. Now, Michael Ortolano and myself are part of the safety committee, so we do have all the safety manuals, etc. So if you do have any questions, again, just feel free to email me anytime you like. My email is dbodwin@absolutehightn.com. It's DBEAUDOIN @absolutehightn.com. Let me spell it out here if I can. Running out of space. All right. So today we're going to cover a little bit of the controls. We'll go through the screens and etc. And the best way to do that is to go to our website. We have a support portal. It's support.absolutehightn.com. And what this support portal has is a lot of information, technical tips, how to pull a screw and barrel off your machine. And it also has simulators. So we have several simulators for all our different machines that we have. And we have the Jupiter, we have the Saturn, Mars, we have Venus, Zephyr. So today what we're going to do is do the Mars 2880 simulator. Again, you just click on the simulator and you're able to download it. Click it here. I'm going to view it. And here's the new screens. So basically, this is your overview screen. This has no information that you can actually change on this screen. It's all virtual and actual values. The next page, when you hit mold, let me do this a little different here. I'm going to download it. And I'll open it with PowerPoint. It's a little easier. All right, so with the PowerPoint, you can actually click on the buttons at the bottom and they'll scroll through the screens. So it's a good learning tool for your employees if you have people that are new or you want to go over screens and you're not quite comfortable with them yet. It's a good tool that you can use to actually go through and look at all the screens. So basically, the top section of the screen, these are static. They always stay the same, along with the bottom. I mean, the numbers change, but the screens stay the same. So any page you go to, you're going to have the same exact pages, screenshots on each of the top and bottom of the screen. This here in the middle is your mold close section. So what happens, it goes from 10 inches to 8 inches at this speed and pressure. And from 8 inches to 4 inches, it's going to be at this speed and pressure. From 4 inches to 3 inches, it's going to be at this speed and pressure. And from 3 inches to final lockup, it's going to be at this speed and pressure. And lockup is going to be at this one. So the Mold Protect is right in this area right here. So this is your mold protection area. What I usually do when I set up the machine is, let me see if I can erase this here. What I do when I go and set up the machine is I actually put all the pressures at max pressure, except for 4 of them. The high pressure close, the mold protection, the back pressure, and hold. Those are the only 4 screens I never use high pressure for. But all the rest of them I usually set up at max pressure on this row here and this row here, injection, everything. I usually use that as a basis so I don't pressure limit my process. And then I just adjust the speeds and flows as I like, whatever speed you like. Once the process is set up, what I usually do is I drop the pressures to where the actual values are by looking at the pressure gauge. And I usually add about 200 PSI just for, so I never pressure limit my process. So the second key is the function key. The function key has different timers on here. So you have your mold protection timer. The actual mold protection value is here. High pressure close off delay and high close on delay. Quick close, you have a quick close button. If you use quick close, it just ignores all the close speeds that you have up until mold protection. So what it'll do is it'll close extremely fast until it hits the mold protection section. Then it'll go into low pressure mold protection. Some people don't like using this, especially if you have a real sensitive tool. It's always better to use it if you have just flat plates with a core and cavity and there's nothing that could get damaged. Ignore top guard, that should always be on. And mold open velocity delay, it's just an open delay if you for your velocity. Anytime you see constant setup, or if you're in a parameter page, these are the settings when it's in setup mode. So setup mode are these speeds and pressures right here. So anytime you hit that little setup button, you close the mold and setup, it's going to be at 363 PSI with 10% flow. Again, you can adjust these if you don't feel that that's fast enough, or if it's too fast, you can lower the pressures and speeds also. Sorry. Over here, you have high pressure hold system, and mold closed before the delay. In this section here where it says stages, that's where you can open and close different stages. So if you actually move these stages to whatever value, it's 3 to 6 that you can go to, it'll actually open and close the values here, these boxes. As you can see, this one's blanked out because it's set for 4, sorry. But when you see you get the 4 here, so it'll only open 4 boxes. The closed profile, that's just for the profile when you're closing, and this is the profile of your open. Injection. Again, you have different stages for injection. This indication here, we're not using all the stages. We're only using 3 stages and 2 stages of hold. So you have your start position here, your pressures, and your flow. Again, when I start my process, the way I always do this is I put the pressures to max pressure, and I adjust my flow to whatever speed I want to inject at. The middle section here is your cutoff or your switch over. You can actually choose all 3 if you'd like, or you can just choose 1 or 2. It doesn't matter. And what happens is the first one that it sees is going to go into cutoff. So whatever it sees first, let's say your injection timer, your injection was 3 seconds. So what's going to happen once it hits 2 seconds, because you have your timer at 2 seconds, it's going to drop the hold right away. These are your hold settings right here. Again, I do not put the max hold pressure. When I set my process up, what I do for hold pressure is 50% of boost. I set for hold pressure. And I do a gate seal off test to make sure that I have my gates are sealed off in that amount of time that I put in the time box. You do that by weighing the parts, and you weigh the parts until the weight no longer changes. So once the weight is stabilized, your process should be pretty good. This function page is a blow up of the cutoff. So this is your cutoff still. You can have an external digital input or an external analog input also. It is not written, but this would be the external analog input. That's for your cavity pressure transducers. So if you have a cavity pressure transducer, you can use either a digital or an analog signal to do the cutoff. This activation position down here is under the pressure cutoff selection. What that does is, because when you have your actual curve for your injection, it's going to come up, it's going to spike a little bit, and then it's going to go up like this, and then it's going to go down at the hold. This little spike right here is caused by the decompression. So once the injection starts to inject and it hits the plastic, because of that void from decompression, it's going to spike. So what this value does right here, it says, do not look for this pressure cutoff until the position reaches this position. And what that does, it just avoids, it ignores this spike right here. Actually, the best cutoff is position cutoff if you don't have an external digital or analog input, which would be like a keister system to do the cavity pressure transducers, which is actually the most accurate cutoff. Down here is auto purge. So you set up your auto purge, select use, and then you can tell it how many counts you want it to do, the amount of time, and just set up your process right here, and press the auto purge button on the screen and it'll auto purge. Sorry. Function 2, we have a cold drop selection. If cold drop is selected, what that does is you have to also have your screw brake on. So what happens is it'll inject, the injection unit will back up, the mold will finish its cycle, it'll open, eject the parts, and close. And then before it injects, it's going to shoot a little slug of plastic. What that does is if you have a material that freezes up real easy, it'll remove that cold slug prior to moving the carriage forward. Intrusion. If you use intrusion, what that does is if you have an 8-ounce shot and you need a 10-ounce, you have a 10-ounce part, you can actually use intrusion. And what that does is before it injects, the screw will rotate at a certain back pressure and speed. Once it hits in the time, and once the time expires, then it'll inject. And what that does, it just allows more plastic to flow into the mold before it injects, therefore giving you a bigger shot size than your actual capacity of your barrel. The graph, that's going to be your injection graph as it's running. And again, you have your parameters, constants, which is when you're in setup, you can change your injection and valve gate pressure and flows when you're in setup. And you have actual times and time delays. You have your maximum injection time, your delay after injection, velocity after injection, your delay inject again. Of course, it's in there twice. And here you have your stages for your different stages that you can have for injection and hold. Charge. This here is your shot size. And this is your decompression or suckback. So your actual shot size on this machine will be 1.0 inches because it's a 0.6 plus the 0.4. Again, you have your pressure, flow, and back pressure back here. This is your decompression pressure and speed. And over here, it'll tell you how you want it, position dependent, time dependent, etc. And you can also turn on your intrusion here. This is suck back before, which is pressure release. So what happens if you turn this on, your machine will inject. Before the screw rotates, it'll decompress a little bit, then it'll rotate the screw, and then it'll decompress again. And what that does is it relieves the pressure off the of the screw tips, so you don't break the screw tips when you're rotating. It's especially important on electric machines rather than hydraulic machines, because electric machines, they have instantaneous torque. And so when the machine says rotate, it's going to rotate at full speed and pressure instantaneously. And the ramping is so small that it really doesn't show a lot of difference. Whereas a hydraulic machine, you have a lot of ramps, and the hydraulics take time to activate the screw rotate. So by the time that happens, you're already decompressed at the screw tip. So it's not really a necessary thing to use this guy over here for a hydraulic machine. Functions, of course, you got suck back before. This is the continuation of this guy right here. This one. So you have your suck back before, your charge time out, and your max charge time. Again, your constant out, that's when you're in setup. Back pressure manual. So if you have your back pressure in manual, you can actually turn it off or turn it on. So if you want to use back pressure in manual mode, you hit use. If you don't want to use your back pressure in manual mode, then you just turn it off. And you can also select a different back pressure when you're in manual. Over here, you have your charge pressure limits, your charge velocity limits, plasticizing delay, max decompression time, pressure, and again, your charge stages. Eject. So you have different modes of eject. You have continuous, you have vibrate, you have tip stroking, which is vibrate, I'm sorry, and you have hold. Hold mode is only used for semi-automatic eject. So when you're in semi-automatic, I'm sorry, what'll happen is the mold will open, the ejectors will go forward, and it'll stay there until you close the door and cycle the process again. Once you close the door, the ejectors will go back, and the machine will continue. Again, that's hold. Continuous, what happens in continuous mode, it goes from the back position here all the way to the forward position. And when it goes backward again, it goes only to this ejector back 1 position, then it'll go to the ejector forward 2 position for whatever amount of counts you have here. So what it is just like tip stroking. In continuous mode, it'll go all the way from 0.04 all the way to 2.35, back to 0.04, etc., until the count counts out. If you need an ejector delay, you have your ejector forward and backward delays. Air blow. There's 4 air blows on the machine. One's on the moving platen, one's on the fixed platen. So actually what you have here is you have your move air blow 1, then you have your fixed air blow 1. This is actually move air blow 2, and this one's fixed air blow 2. And just tell it what activation position you want, if you want a delay, if you want an actual time, and select them to use them. Function. Use the ejector backward function. What that does is it allows when the mold closes, it'll put oil on the front of the ejector cylinders to hold them from going forward during mold close, which if it does go off if it does move while the mold is closing, it'll shake off the limit switch and the mold will stop in mid cycle. So using the ejector backward function is useful for molds that have big plates that are really sloppy, and you need to have that extra oil to keep the ejectors back. Ejector backward time is used in correlation to that one. So whatever, just put a time in there. So when the mold closes, if it takes a half a second, put a half a second. If it takes 1 second, then put 1 second. This link, that's eject on the fly option. If you use link, then you'll have the activation position that you want the eject on the fly to work. Every machine has eject on the fly, but if you don't ask for that as an option, what happens is if you use it, the mold will open. When it gets to this activation position, the mold open will stop because it takes the oil from the mold open and converts it over to the ejector. The ejectors will go forward, and maybe the momentum will be enough to allow the mold to open more, but sometimes it just stops. So what happens if you ask for eject on a fly as an option, they add an extra pump into the machine. So the pump will actually act as for the extra ejector and core on the fly option. So if you do want eject on a fly, you have to ask for it as an option. And they put a second pump. Mold mounted, that's for a mag plate, not used for a lot of different companies. Constant out again, that's for your ejectors when you're in setup. Then you have a ejection ejector pre-stop position and ejector pre-stop velocity. On the cores, you can choose time, limit, you can use time, you can use screw count, or you can use a limit switch. So if you use time, then it'll go off a timer. If you use limit, then it'll go off a limit switch. And if you use the screw count, it'll go off this counter. What'll happen, you'll have a box here, and it'll actually count the RPMs of whatever device you have. So if you have a screwing core, you can actually use that, and the machine will count the rotations of the proc switch. Again, if you guys have any questions, you can also email me with the questions, and I can reply that way. I know it's a little tough to do it this way, but on the core, you actually have core link also. So core link would be over here. And that's core on the fly. Again, you need another pump if you want it, and it would be the same pump that would be used for the eject on the fly would be used for the core on the fly also. And this is your Euromap robot settings. So you can tell if you had multiple cores, 5, 6, 7 cores, whatever, you can tell what core you want the robot to activate off of. So if you had core 3 in there and you wanted the robot to run off of core 3 instead of the ejectors, then you can do that. So whatever core you would like the robot to activate off of, you can select it right here in this box. These are just set up for core in, core out, core B in, core B out, different pressures and flows. You got a core tolerance here, core cushion, and max core move time. And the second parameter page, you have a bunch of different delays. So you can actually set up delays for your cores. All right. This is your carriage settings. So you have a pressure flow and time also. The time is used for your screw brake. So if you put the back mode on, which is your screw brake, it'll go back based on the time. So if you use the timers, what you'll find when you go into manual and hit the carriage back button, it's going to stop at whatever time you put in this box. The way to overcome that is just put the machine in semi-automatic, setup, and then push the back button, and it'll just ignore the time. This is your die height, speeds, and pressures. All right. So again, if you have a bigger mold, then you may have to increase the die height, speed, and pressures. If you have a smaller mold, then keeping them low is the more suitable. You don't want to add more pressure and speed than necessary, so keeping those at a minimum is always the best. We have a nozzle.
So I have a question.
Yeah.
So back in the last page where you got your nozzle touch,
Yeah.
do you have that page? Yeah, in that page. But one of our items, it has it has the nozzle and position.
Uh-huh.
Do you have
So
that
you have a
page?
um you have a nozzle in position. I don't think I do have that page. It may be on one of the other simulators.
Because we have two. One of this page you have right now, which is in
Mm-hmm.
timing, and the other one it works by position.
Oh, so you have a transducer on your carriage.
Yes.
Yeah. Okay. I believe the newer machines have transducers on them, and what you have to do is you have to zero them out, correct?
Yes.
Yeah. All right, that's it's the same thing on the ZE machines and the VE machines that are the new series. They have the same function where you actually bring the carriage forward and press the zero button. When you do that, what I recommend is closing the mold, bring the carriage forward, hold the button, carriage forward, and then press the zero button. That'll give you your most optimum zero position for the carriage.
Okay. Thank you very much.
Yep, you're welcome. So you have your nozzle delay forward, nozzle delay back, and your mold weight. Use robot. That's important to turn on if you're going to use a robot. If you don't turn on use robot, what'll happen is the machine functions will not communicate with the robot. So the machine, what it'll do, let's say you want the mold to open and the robot to come down, it won't happen. It'll just stay there. So your cycle won't be 100% accurate. So if you're using a robot, you have to make sure you select use robot. And the 3 other buttons are for the auto die height also. Again, you have your speed and pressures for your nozzle forward and back when it's in setup mode. You have your nozzle value delay timer, nozzle release pressure and time, max nozzle forward pressure, max nozzle backward pressure, max nozzle velocity, max mold adjust pressure, and max mold adjust velocity. Oh, sorry. I think we're all done with that anyways, right? Okay. Temperatures. You have your plus and minus tolerance here, which is the deviation from this value here. So if you're out of deviation, what'll happen is you'll have an alarm. The alarm will go off saying that you're either at too high or too low of temperature. This keep warm function, if you use keep warm and at a time, what'll happen is whatever temperatures you have in the keep warm section, the machine will actually shut the heats off and maintain that 212 degrees for whatever time that you put in a timer box. So for instance, if you have a PVC machine and you know that you're going on an hour lunch or something, use the keep warm, put the keep warm time for 60 minutes. And what will happen is the temperature will lower itself to a safe temperature. And after the 60 minutes, the heats will come back on and it'll heat up again. Cool prevent, that's so you don't break the screw tip when you're turning your machine on and it heats. So you want at least 10 minutes of soak time to allow the temperature to reach the inside of the screw. You have a couple temperature modes. You can put in set. Some machines that are PVC will have PVC mode. And the set, if you change the set, you'll have a percentage right here that you actually tell the machine what percentage of power you want the heats to go on. So that's if you lose the thermocouple or something. You can also you can always change it to set, which is the manual mode on a regular machine. Your hopper temperature, that's for your feed throat temperature. You have a little calendar right here, so you can turn your heats on and off at a certain time of the week. So let's say you only run Monday through Friday, and you want your temperatures to start up at midnight on Sunday, you can actually select this guy right here, and the temperatures will go on at 12 o'clock a.m. on Sunday, and it'll be ready for you to run. It's good if you have a lot of machines and you want to spread out the demand. You can actually set these things in 15-minute increments. So all the machines will be turned on with the heats, and it'll increment every 15 minutes. It'll turn another machine on with the heats, and therefore you won't have a big power surge or demand. Oil preheat. I don't ever recommend using this because with these servo machines, the oil temperature usually goes plus 5 to 10 degrees above ambient temperature. Because there's no check valve for the oil to dump over, the oil never really heats up. So what will happen is it'll just, you'll run this oil preheat, and once it reaches this temperature, it'll start cooling again because there's nothing to keep it from staying hot. So the machines are designed that they run perfectly well with the ambient temperature plus or minus 10 degrees. I haven't seen any problems at all. In fact, a lot of customers don't even use the heat exchanger, which, yeah, you should hook it up, but a lot of people, I know a few customers that they don't even use the heat exchanger because the oil temperature never goes above 90 degrees. Group heating, what that does is it turns all the heats on at the same time instead of having your heats heat up one zone at a time. Like you'd have your nozzle heat up first, then the front zone, then the center zone, then the rear zone. Group heating, that allows all the temperatures to come up evenly at the same time. Then you'll have a minimum temperature change, so it'll keep that tolerance pretty tight for 32 degrees. So if you want it even tighter, you can actually lower that to whatever temperature you want the minimum temperature change to be. And here's the tolerance between zones of 5 degrees. You have your upper tolerance and your upper heating filter. Again, here's your oil temperatures. And I don't think I've ever seen a single machine in the field go off on any of these alarms over here, because the oil, I haven't seen any oil ever get that hot. I may be wrong, but personally, I haven't seen it happen. This is the servo motor temperature. The servo motor is oil cooled, and again, that's the only thing that's going to heat the oil up is keeping the motor cool. And if you have a fan, then you'd have a different fan temperatures. And then if the motor gets above 185 degrees, it's going to shut the motor off. You'll have a motor overheat error. Quick, this is a overview of all the tabs we just covered. So this would actually make a good cycle sheet. So if you guys do manually print out cycle sheets, you can just print this page, and that would print out exactly like this, and it's a good tool to have just for reference and stuff like that. The way you do a print is you actually push something, one of these top bars right here, anywhere in that area, and what'll happen, it'll come up with a print menu, and you just tell it what the file name you want it to use, where you want it to print to, usually a USB drive, a USB stick, and it'll save that. It'll save the screenshot to the USB stick. This presentation was actually all done with screenshots from the actual machine. And again, if you want to open and close stages, you can go to this page and open and close your stages for your mold. Open and close your injection, hold, and charge. And then you have a bunch of timers, which you can actually alarm off of the timers. For example, if your mold close timer, you can change that to like 3 seconds. So if there's a problem inside the mold, after 3 seconds of trying to close, it'll give you an alarm. And that's it for the process pages. The rest are alarm pages. So this is your alarm, well, other miscellaneous stuff. Anytime you clear an alarm, this alarm screen also clears, so you'll have no data. So what happens, you have to go to quality and no, not quality, sorry, manager, info. And manager info, you have a filter here. So what this manager does, it tells you all your changes and your alarms. So if you change that filter and just say you want to look at all the alarms, you can then look at all the alarms. Right now it's showing you all the changes that happened and who changed them. So if you highlight that, it'll actually show you the full value down at the bottom. You can have a good readout of it, so you'll know exactly what it was. For example, this guy here, they turned the preheating to no, and over here they turned it on to use. IO monitor shows you all the inputs and the outputs. Now, all the outputs can be forced by just clicking on one of these little round circles. You go to the output that you want to look at. Of course, these are inputs, so but you just push on the circle and it'll ask you if you want to force the output on. You have to do that with the pump disabled, the drives disabled. So you do not push the drive on button. And you can always force the outputs. So it's a good troubleshooting tip. You have a problem with a valve or something, you can actually force the output, go to the valve itself and check to make sure the signal is getting to the valve. If it's not, then you can trace where the wires, where the error is on the wire. Quality, this is your quality monitor page. So you can actually alarm off of this page, or just monitor. So what this does, for example, you have your bad part count, your good part count, your percentage of bad parts versus good parts, your interval, and your bad part limits. What this does, your interval and your bad part limits, let's say you said you wanted 2 rejects for every 100 parts. So you would set up 100 for your interval, and bad part limits would be 2. And so if the machine sees more than 2 rejects per 100 parts, it's going to alarm out, providing you select the proper boxes down and below. So for example, mold close, you have your actual, then you'll put your set time here, your tolerance plus or minus. So over here it'll be if the mold close is more than 2.5 seconds or less than 1.5 seconds, and you monitor it and you alarm. If it sees it go out of tolerance, then it's going to alarm and the machine will shut down. Only after 2 rejects per 100. If you keep that at 0 and 0, then it's going to alarm every single time. The most important process to monitor is injection time, charge time, your switch position, max injection pressure, and your hold end position. PDP, this process data screen, what it does is just keeps track of all the 20 shots, and at the bottom it has some statistical analysis, so you can actually do some statistics off of your process. So how you set this guy up is you hit this setup button, it'll come up with a box, then you can choose what you want to monitor, select the values you want to monitor, hit save, go back out of it, press the start button, and it'll start monitoring all your data that you want to look at. Process data graphs, that just gives you some graphs. If you want to look at different graphs, you can actually do the same thing. Hit the measurement, select what you want to look at, and you can look at the graphs. Same with the PDS. Sorry. Explorer is pretty neat if you want to save all your setups. So for example, if you wanted to save all your mold files to a USB drive, all you have to do is pull down this menu and it'll say mold files. And all the mold files will show up here. So you take your finger on the first one and hold it down. And what that'll do, it'll select all the files. Then you can just go to the tools, select copy, go back down to this pull down to USB, put a USB drive in there. Select USB, go to tools and paste, and all your setups will be saved to a USB drive. You can do it all in one shot doing it this way. Scope shows you all your RPMs and some of your hydraulic values. You can keep track of that. It's just like the PDP, PDG, and PDS. Mold data, these are your setups. Again, the drive, if you hit that drive, you can also save your setups to the USB. Doing it the other way saves everything all at once. Doing it this way, you can only do one file at a time. Manager, this is your box counting and good parts, bad part counting system. This auto delay was a tricky one way back when we first started. This is your mold close delay time. Mold, I can't spell, close. So that's mold close delay, is your auto delay. So if you ever see that your machine is hesitating when it goes to close, it's probably because the mold auto delay is pretty high. This is a part drop timer. You can use this photo cell. The photo cell will see one part drop in front of it. If it sees a part drop in front of it, then the cycle will continue. If it doesn't see a part drop fall down, then the machine will not close. So it's kind of a safety for bigger parts that you want to make sure that the parts are rejected off the machine, off the mold. You have your cycle count, your good parts, number of cavities, bad parts, remaining parts, and your product package counter. Then you have your production time done and production time left, average parts per hour, production today and production made yesterday, and your motor running time. SW off is to use for lights out operation. So if you want to continue running your machine without it being attended, you can actually do that by selecting use. Put a time in here. So this time is an alarm time. So if it sees any of these alarms right here, after 15 minutes, for this example, what will happen if you select this, the machine will actually shut down after 15 minutes. If you say switch off after cycle, what will happen is it'll just shut off right away. The notes area, you can just write notes to the other shift, or you can just set up, guy can put whatever notes he needs in there. For example, how many water lines is on the mold, or what, all that information that he needs for that setup. This does get saved when you save the part, save the mold file. So it is going with the mold file. And again, we covered info already. Sorry about that. Come on. Where was that? Version. Version is just information. If you have a software update or whatever, you need to have the control version. So you would actually give the Ron or Randy or Lyle or whoever this information so you can get a update of your software. For example, if you request some special options, then you need to get all this information to them so they can actually give you the right software update. Can anybody see?
Nope.
I think I lost my screen. Sorry, hold on. That phone call messed me up. All right. Setup. This is where you can use your users. You can change your passwords. You can actually assign a password to every employee. They can have their own language. They can have their own level of access, etc. If anybody wants to know how to do that, you can actually email me and I'll give you instructions on how to do that. Up here, you can select your language, your screensaver time, your date and time, what units you want, if you want metric or imperial. This tells you what level you're at. A display that just allows you to shut the screen off. System is just information that's what the factory needs for doing different modifications. Lock, you'll lock the screen. Report if there's a software problem. Back in the old days, we used to have to give them a report. So we would hit the report button. We'd give them a report that we can send to the factory for the software. Mask just gives you access to different addresses and stuff like that. That's again only used for the service guys. Analog calibrations. This is very easy to calibrate these machines. What you do is you put your, like for example, for your mold. Damn it. Oh. Again, I apologize. So what you do, you put your mold position to 0, which is lock up. Whatever value you get in here, these are voltages. Whatever value you have here, you put it here. So then you move your mold all the way open. And whatever value you get here for voltage, you put in that box. And you do the same thing for all the transducers. To do your injection pressure, I'm doing a webinar. I'll call you back. So again, you can do that for the ejectors. You have your ejectors at 0 position. Whatever value you have here, you put in this box here. For injection, obviously when nothing's running, you're going to have 0 bar. So whatever voltage you have here, you put here. And you put your max pressure in your hold. I use hold and I would turn off the injection. I put hold for like a time of 10 seconds or something. Press the injection button until it gets the max pressure and hold, and then whatever value you have in your voltage up here, you put in this box here. Same thing with system pressure. System pressure and injection pressure would be almost the same value, unless you had multiple pumps. And this is just your display your mole graph. Analog output calibration. What you do here is you put a pressure and you look at the gauge. If the gauge is lower than the pressure that you're set at, again, you can use hold. Let's say you put the hold at 290 PSI and it's actually showing 240 PSI. All you need to do is increase the voltage until you hit the 290 PSI. And you do that for your flow and your back pressure also. It's kind of hard to do the flow because you don't really know what the speeds are. So basically, I would just worry about the pressures and the back pressure. Inverters, you don't have to worry about that at all. The pressure graph and flow graph, that'll just show you what you've just done. It should be a pretty linear value. MACH1 is factory set values. The only thing on this page that you should ever have to change, because they said they're pretty low, is this ejector end limit. What that is the minimum, or hold on one second. It's the value that you, for your ejector back, the minimum. So let's say you tied in your ejectors and there was a 2-inch difference. So when you send your ejector back, it's actually at 2.0 inches. Well, you wouldn't be able to change it because it's set at 0.39 inches. So what you have to do is you have to go over to that setup page, machine 1, and change the ejector end limit to 2 inches or 1.5 inches or something bigger than what the actual value that you're looking for is. Machine 2, these are your ramps for your open and close and injection, hold, charge, suck back, ejector nozzle, and back pressure. And these are the ramps when it's in setup. Never have to adjust those. These values are kind of sensitive. They can either make your machine slam or you can make your machine run real smooth. It's always best to have your service guide adjust those for you, or do them over the phone with one of the service techs. Machine 3 is just, again, factory information in your startup language and default language. Machine 4 is your auto lube. And the temperature is on the temperature PID page, you can actually optimize your heats. So if this little box is green, then you can select this optimize button, turn the heats on, and it'll automatically calibrate the heats for you. PID, you don't have to worry about anything there. Variables, you don't have to worry about that. Engineering page, the only thing that you would have to do on this is make sure if you're using a robot that this use robot is turned on also. And if you're using different types of thermocouples, you can change them right in these boxes. If you change one, change them all to the same type. You never want to mix thermocouple types. So you can actually have J or whatever thermocouples you want to use. Actually, K is the most accurate and the best, highest temperature zone. So that's usually the best thermocouple to use anyways. Engineering pump. Some people have this button and some don't. That's so that little cycle start button on the front of the machine, you don't have to use it on some machines. So you just disable that and you don't have to use your cycle start button on the front of the machine. The rest of this information is for different pumps. So if you had eject on a fly, so you'd have a 2 here, and all of these would be 2 also. That's just telling the machine, hey, you got a second pump So pump 2 is for the ejectors, pump 1 is for everything else. And the engineering ramps, ramps that are not even their factory set, you can't adjust any of them. And that's it. So that's it for today.